Please welcome Mr. Yogesh with a huge round of applause.
So, thanks a lot. Thanks, UBS, for having me here. Good afternoon, gentlemen. Although this is after lunch, so I'll make it as light as possible. So I'll talk about optimizing distribution network in the complete supply chain ecosystem. What we're going to cover is about 4 to 5 topics. One is understanding the complete distribution network in the complete supply chain in any industry. Normal challenges that distribution optimization network faces in any scenario. What are the best practices for expanding market reach, leveraging technology in distribution, cost reduction strategies in the supply chain. Then we'll also deep dive into a case study that we implemented during my past stint in the organization, and some of the key learnings and takeaways from the case study that we did. Then first is understanding the distribution network. So what is distribution network in a very simple way? So it is about, it comprises of interconnected businesses and facilities that delivers goods and services to the customers. So what are these facilities? These facilities might be probably factories, warehouses, retail outlets, distribution centers, wherein your goods and services are delivered to the customers. Now, understanding what distribution network is all about. So there are various types of distribution networks that a supply chain professional goes through. I'll highlight a couple of things. One is centralized distribution network, which is where you have fewer warehouses, which might have low cost. However, your speed of delivery would be high. Secondly, decentralized distribution network. Decentralized distribution network would have multiple regional warehouses in your complete distribution network, which will enable you for faster deliveries, but then your inventory cost would be high. Third could be a drop shipping model wherein the inventory storage cost is less, the handling is less. You may do a cross docking so that better handling of the complete inventory. Fourth might be direct shipping to the customers without involvement of any distribution network from the manufacturer to the customer. These are the three to four different types of distribution networks that we encounter in a complete supply chain. Now, how do we build the complete supply chain, and what is the importance of having a distribution network in the complete supply chain? One is you would want to penetrate in a specific market, taking into consideration your customer locations, customer preferences in any industry. That could be one thing which is crucial for penetration of any market, and that would help you to basically define the complete distribution network in the supply chain. Other current trends in the supply chain network, in the distribution network, if you are aware of in the quick commerce ecosystem, once your products are listed on the quick commerce platform, then the first fill or the first replenishment that happens from the warehouse to the dark store or probably the mother warehouses of the quick commerce ecosystem are appointment based. Now, in the current scenario, taking appointments from the quick commerce platform is in itself a tricky situation, because due to capacity constraints in their warehouses, you might not get appointments on time. That's one. Second is also because your appointments getting missed, because quick commerce, as the nature of the quick commerce is fast delivery, and therefore the inherent capacity constraints in the quick commerce ecosystem, because of which the appointments could get missed. So this is something which we are facing problem in our Welspun ecosystem as well, and therefore we look forward to any kind of freight forwarders, carriers who can sync up with us to solve this problem, because currently we are facing this problem. However, what could be done, which to some extent we tried doing it, is basically to have a collaboration, strategic partnerships with partners who have strategic partnership with quick commerce platforms. So for example, let's say Blinkit. Blinkit has a strategic partnership with one of the prominent players in the logistics ecosystem. If you partner with that prominent player, you would be in a better position to have your deliveries done on time, appointments not being missed. So these are a couple of trends that are that you witness in the complete supply chain ecosystem. Some of the challenges that a distribution network faces is, so let's say you were able to figure out a distribution network in your ecosystem, in your industry. Then what are the typical challenges that you faced? One could be, a misrouting kind of thing, wherein, due to inefficiencies in the transportation system, you were not able to deliver the materials at the right time, and therefore your SLAs are getting hit. So that's one prominent problem in the entire distribution network. Now, how you can solve this problem? So if the problem is delivery, if your problem is slower rate of deliveries, and therefore you want a faster delivery in your complete ecosystem, one strategy could be getting close to the customer, and that is what we tried doing it in our last organization. I will delve into the case study that we did as a project in the last organization. Wherein you go to the customer, you go near to the customer, you build your complete distribution network in a manner wherein you have multiple warehouses. So that two things can happen. One is, because you are closer to the customer, the delivery TAT, the last mile TAT has shrunk down. Second is, the secondary logistics cost would go down just because you are near to the customer, and therefore the potential of utilization of FTL would be high compared to PTL. That improves your complete FTL to PTL ratio, and therefore your secondary logistics cost or the last mile cost would go down. So that is some of the strategies that you can apply from the distribution standpoint, and that what even we did in our earlier organization. Cost implications. Now again, if your distribution network is not made in a manner wherein your customer preferences are not satisfied, then the complete operational cost goes for a toss. The complete transportation cost goes high, and therefore you are not able to, it hits your margins basically. It erodes your margin because your operational cost is high. And therefore, to reduce the operational cost, how distribution network helps you to revamp, how distribution network helps you to optimize your complete warehousing operational cost. That is something which we will see in the case study that we are going to delve with. Now again, because the cost is high, it also impacts your customer expectations. So since you're not able to adhere your SLAs, because of which your customer expectations would go for a toss, because of which your NPS would go for a toss, and therefore the churn of orders will again have an impact, and it will impact your top line as well as the bottom line. So these are a couple of challenges that any supply chain leader faces in terms of distribution planning. So how do we make sure that best practices are followed to expand or to have better presence in every market? One is, as I mentioned before as well, to understand your customer, you need to do a customer segmentation, which inherently implies that you need to understand your customer, where they are located, what are their preferences, what's your product, whether that product whether that distribution network will hold true for that particular product, or you need to have a different distribution strategy. That is something which the person has to gauge to, and then only he can design the complete distribution network. So segmentation is important to understand the complete market and the customer. Second, as we go along to build the complete distribution network, technology will play a very important role. So I was talking about misrouting of shipments. So AI would help. AI would come handy, wherein they would help us to give us triggers at those points wherein your shipments are getting delayed. And once those triggers are given to you, probably you might be in a better position to take corrective actions on it. So these are some of the technological interventions which can be given to expand the complete network. Third is collaborating with the local market. So let's say, for example, you revamp your complete distribution network, wherein, let's say, in a tier 2 or tier 3 city, you want to collaborate with 3PL partners. It is better to have partnerships with those 3PLs which are regional strong players, because they understand the markets well. You have low entry barriers there. Your customer preferences, you will be able to gauge customer preferences well, and therefore you will be able to cater to them in a better manner. So all those things would help you to basically expand your market and have better presence in the market that you intend to. Again, from the technology standpoint, as in the previous sessions, many of the speakers mentioned about AI, IoT, ML, etc. Although in the distribution network, all these technological interventions will help to take corrective actions on it. But then one of the typical things that we did at Welspun from the AI standpoint is however this project is at a nascent stage, we are doing an AI-driven forecasting wherein you give that algorithm an input, a set of inputs. It will give you a situational based output to it, and then you trigger it out which situations hold true for your company, for your organization. Based on that, you decide what needs to be done for that particular forecasting. And this is done based on multiple algorithms, multiple network modeling techniques. For example, it is ARIMA, SARIMAX, Profit, etc. So all these tools, all these models facilitate to gauge which distribution network holds good for your organization. It is just a facilitator. However, it involves manual intervention to understand which situation holds good for your business, based on multiple parameters: in which industry you belong to, what are your products, which customers you wanted to cater to. So technology would be a enabler here. Cost reduction strategies, again, in the cost reduction standpoint, I'll be more focused towards cost to serve, which basically involves warehousing and logistics cost. So when you break down the cost of warehousing and logistics, it basically involves in warehousing. What are the cost components? It is the fixed cost as well as the variable cost. In the fixed cost, majorly these are rentals. Rentals, the better you are able to negotiate rentals with your 3PLs, the better you are in a position to reduce the fixed cost of the warehouse. Similarly, from the variable cost standpoint, the better you are able to negotiate again with the vendor in terms of which manpower you require for your operations. What I mean to say is, let's say you don't require a supervisor because the inherent nature of your business is such that you don't require a supervisor. It is just picking, packing, and just the dispatch. So probably you can have a cut down there. So all those little tweaks you can do to basically bring down the cost at an efficient level where you want to. In the similar fashion, in the logistics cost, what it is, logistics is basically PTL, FTL. The better you are able to utilize FTL, the better your per kg cost would be. If you are utilizing PTL more, the cost would be relatively higher than an industry which is using an FTL load. So how you can improvise, how you can improve the FTL PTL ratio so that you reduce the cost. And for that to happen, you can do 2-3 things. One is basically consolidation of orders. So on a particular route, so let's say for example, you define a route and orders, you consolidate it over a period of time. Once you consolidate these orders, you place a vehicle, and that vehicle does a milk run on that particular route, milk run consolidation, so that your entire logistics cost goes down. So these are some of the interventions that can be done from the logistics standpoint. I'll just move towards one of the interesting case studies which we implemented in our previous organization. So we were tasked to reduce the complete cost to serve, which includes warehousing and logistics cost from somewhere 7% to under 5%. Analyzing the complete data, breaking down the cost into various cost components, we realized that the secondary logistics cost was coming out to be 65% of the total cost. And why was that? So the secondary logistics cost was high because the distribution network of that organization had only one warehouse from where pan-India fulfillment was happening. And since they had only one warehouse, the secondary logistics cost, the last mile cost was high because they were utilizing FTLs and PTLs, and the per kg cost was somewhere in the range of 15 to 16 rupees per kg. So we were given a task of reducing this cost, taking into consideration all these factors. The problem statement was basically, so what were the problems when this happened? Analyzing again, we came to know that the complete NPS of that organization was around 32, which is not good from the industry standpoint. Then the customers were not happy because they were receiving the orders in 6 to 8 days of time because they had only one warehouse, and that one warehouse was used for pan-India fulfillment. And again, the cost was high to an extent of 7%. So what we did, the objective of this project was to basically cut down the cost from 7 to 5. But more than that, it was also about giving the complete visibility in the complete value chain. Where are your costs? Which steps are contributing higher cost to the complete value chain? Again, improving the customer experience, NPS, which I just spoke about. Optimize the complete logistics and warehouse cost, and again the distribution planning. So after analyzing all those things, working on the solution, we realized that if we go near to the customer, proximity of the customer was one of the biggest interventions that we did. When we go near to the customer, two things can happen. One is, again, the last mile cost would get down because we are closer to the customer, and therefore we'll be able to serve the customers by utilizing FTLs more and PTLs less. Second is we'll be able to serve customers in a shorter period of time, and therefore the last mile TAT would reduce. So that was this realization, and to validate this was a hypothesis that we made, and to validate this hypothesis, we created a network optimization model using k-means clustering. Using our programming. So what does this k-means clustering talks about? So k-means clustering is nothing but basically there are the input variables that needs to be given to the algorithm is the demand points and their weightages. What are demand points are basically where your customers are located. So demand points along with their weightages. The second thing is the secondary logistics cost, primary logistics cost, and the warehousing cost, and the desired service level agreements that you intend to build once your distribution network is established. So all these variables, all these decision variables were given to the algorithm, and through a k-means clustering network optimization model, we were able to give these input variables at a length which took us time to also collate data and then give those variables to the algorithm. And when we ran the algorithm through k-means clustering, the algorithm was able to give us optimized number of warehouses that minimizes the distance between demand points and the centroids, which is the warehouse in a particular cluster. So what this k-means clustering does is basically you give the demand centers to the algorithm, and it is a sum of squared of demand centers and the centroids in a particular cluster. So let's say you have given 1,000 data points to that particular algorithm. The algorithm will churn that complete data points based on the inputs that is provided to them, and it will make clusters, multiple clusters into it. Now it is your prerogative whether you want to give one cluster or multiple clusters. So let's say, for example, you give 5 clusters. So the algorithm will give you 5 different locations with lat long where your warehouses needs to be expanded, and based on those warehouse lat longs would be the optimized number of warehouses that needs to be expanded by your company. So that way, the algorithm was able to give us around 9 number of warehouses in the complete ecosystem. And then once the algorithm was able to give 9 number of warehouses, we were a bit skeptical whether it will work for our industry. So we did a simulation model. We created a virtual ecosystem wherein we simulated the complete data. We tested it, we validated it. Once that testing and validation was done, we were able to see the output in terms of cost getting reduced from 7% to 5%. Now all this was something which we did on algorithm, which was all theoretical. But we also wanted to scale it up through a pilot. So we started with one location in the north region, one location. Out of 9 locations that the algorithm had showed, we started with only one location. We conducted a pilot for a month, 1.5. And we saw the results. And the results were only 3 things. One is whether you are able to serve your customers within 24 to 36 hours. Second is whether your secondary logistics cost is getting reduced. And third is if you're able to do 2 things. The third thing is NPS. NPS would go high if you're able to serve your customers at a faster rate. So we saw these results by doing a pilot in one location, and therefore in a span of 5 to 6 months, we were able to expand to 8 different locations, which is basically in total 9 locations. And after expanding to these 9 locations in a span of 5-6 months, we again tried to do a validation whether we are able to derive output out of it, what we had envisaged during the initial stage of the project. So over a period of time, we realized that we are able to serve the customers in the minimum possible TAT. We are able to serve the customers in shorter period of time as well as at a reduced cost. The secondary logistics cost went down from 65% to around 35%. So these were some of the things which we did to understand whether we are able to achieve that output which we had envisaged in our initial project ideation. Now, the biggest problem that we faced was from the distribution planning standpoint, because earlier we had only one warehouse, now you have 9 warehouses. You have to distribute the complete inventory across 9 warehouses in a manner wherein every location has right amount of inventory at right point in time, so that when the customer orders, you will get those products with a at least 98% fill rate. So for that to happen, we again went through an AI model forecasting, wherein we did the complete distribution network planning. And through an AI modeling, we were able to achieve at least 98% of the fill rate because we were able to do that distribution planning in a manner which we wanted. It is also about, so AI is not about just having right tools and techniques, but it's also about giving right data as an input to the algorithm. If you give garbage in, so it will give you garbage out. So the input data has to be healthy. If it is healthy, it will give you the desired results. So those things we did. As I mentioned, the FTL PTL ratios improved by 44%. Customer experience went to 52, which is 68% improved. So some of the delays that we faced was from the software implementation standpoint, which was WMS and OMS. However, we were able to pick it up in some manner. Now, how did we pick it up is basically we prioritize some of the things. Let's say from the integration standpoint, there are 5 different things which needs to be done. We prioritize 2 which are most important must-haves, followed by good to have, and then the next, so that it doesn't become a bottleneck to the complete projects. That's how we prioritize the complete integrations in terms of WMS and OMS. So what are the KPIs that we gauged after the implementation of the project? Transportation cost went down. It was around 14-15 rupees per kg. It went down to around 6 to 7 rupees per kg. Inventory turnover ratios were good. Delivery times, as I mentioned, 24 to 36 hours. We were able to we were able to cater to the customers. So some of the key takeaways and learnings from the case study. Start with the data-driven market analysis. As I mentioned, this we did with the realization that if we are able to give healthy input, we will be able to derive healthy output. Redesigned the complete distribution network. Again, we redesigned it as I just mentioned. Leverage static partnerships. So there were 9 different locations, out of which some of the locations had problems with respect to unions, manpower, etc. So that needs to be embraced and solved by strategizing those things. So we did that. Invest in scalable technology. Again, AI was used. K-means clustering was used as a network optimization model. Focused on agility and flexibility. Pilot programs before. So we did pilots before scaling up. So these are some of the takeaways, learnings, and prerequisites when you need to implement any distribution strategy in your organization. So future trends, I mean, everything is pertaining to sustainability now. I mean, every organization is environmental conscious, and therefore they are tweaking their packaging, etc., to make sure that they are environment friendly and they don't contribute much from the ecosystem standpoint. However, distribution network again will play an important role here, because there is a flow of information and product from one place to another. Therefore, it has its own importance. So these are some of the things which we did from the distribution network optimization standpoint to ensure that we land in a situation wherein what we had envisaged from the output standpoint, we get that output. So that's all from my side. Thank you all for the attention.